Hi, I'm Kyle Butt. We're going to talk about some of the advanced features and implementation details of Rholang. Specifically, I was asked to focus on to help people get a better understanding of deterministic unforgeable names. Hopefully. Spatial matching. Hopefully you know something about unforgeable names, and because I'm going to be focusing on the deterministic part, I'll stop in the middle and have an opportunity for questions just about deterministic unforgeable names, and then we'll go into just some of the details on spatial matching. And Mike brought up one in a conversation that's not on my slides, but we can go into that one. All right, so Rholang uses the idea of unforgeable names as opposed to private names. It's important to remember that there's nothing private on the blockchain. Everybody gets to know all of the things. And the names are unforgeable because there's no, when we take user input, we accept it as a textual program. And there's no way in the grammar of the textual program to write the unforgeable names. So one of the easiest ways to do this is to just choose random names. The problem with that is that when someone goes to replay your code, I know Mike talked earlier about how we handle the replay of the non-determinism in Rholang, but now, even if we've got that covered, when we go to replay, we want the names that are chosen by each node to be the same, so that you can so we get consistent results. All right. So I looked into. So this is kind of a solved problem, right? Like we want something random, but we want it to be predictable, so we'll use something that's pseudo-random. This has been around for a long time. There are even cryptographically secure random number generators. For example, SSL uses that to, so with SSL and a DSA key, you exchange a single secret, and then you use hashing to extend that secret to generate all of the session keys that you need for SSL to work. So using a PRNG to do something like this is straightforward in a standard sequential imperative language. I would be surprised to find an imperative language that didn't have a random number generator library already packaged with it. In a functional language where you're trying to be pure and you don't want to read from outside state, and you want to not be dependent on evaluation order. This is also solved. There's a great paper from 2013 about splittable pseudo-random number generators using cryptographic hashing. And the approach that we took is very much based on this with some extensions because of the specific way that Rholang does things. All right, so we took advantage of the fact that Rholang terms have a normalized representation, including sorting. And even if the order in which each piece runs is not determined, we can assign each piece a split of the random number generator in a deterministic way. So we can have non-deterministic ordering with deterministic splitting. So in my initial implementation, it seemed like only the things that had continuations, additional code to run, would need a piece of the random number generator state. So the body of a for, the body of a new, and the body of a match case. Right? As we run those things in parallel, they're going to there might be another new hiding inside of it somewhere. So the problem with this is if you have a replicated 4, the random number generator state gets stored once. And then we load it back up, and we run it. And the first time, this is lovely, but the second time, we generate the same deterministic unforgeable name. It turns out they were a little too deterministic. I should have put in the XKCD slide about 4. So that was the problem. And so the solution that we came up with is, that solution necessarily means that when you have things that produce sends, that you send some random number generator state along with those as well. That part of the solution is inescapable because otherwise everything is determined. So at the moment what we do is we take the random number generator state of the 4 and the random number generator state of all of the incoming data, and we merge them. And that means that each COM event uses you can read the formula, but we do some number of hash computations. In the majority of cases, that's 1, and it's always going to be 1. In the hash implementation, I merged the full 512-bit state, and so it's 2 to a 1024-bit block. And I should have mentioned we're using Blake2B, just because I like it and it's sufficient. We also use it in several other places in the project, so we're just being consistent as well. So we could shrink that to by a constant factor, and that would mean that unless you were joining more than 3 channels, it would be a single hash operation. And I might very well do that. Because the names are 256-bit strings anyway, this really wouldn't increase the collision probabilities. Although if you do get a collision, in this case, it's just fine. I was just thinking about it. I realized you'd have to generate multiple collisions, but it still does lower it doesn't really affect the overall security. So how do we merge random number generators? So I spent like a Thursday and a Friday reading a bunch of papers, and then I swear I dreamt about crypto like for 2 nights. And then by Monday, I had worked out all the proofs that it was correct. It was great. So I know the general rule is don't do crypto yourself, and I'm not doing anything crazy. One of the things that we did is there's a paper, Sufficient Conditions for Sound, Tree, and Sequential Hashing Modes. So what we're doing is we're viewing the merges as join nodes in a tree hashing mode. And so as a quick rundown of what the paper says, and the paper itself is really fun, and if you want to grab me after, I can show you the paper and we can go through it in more detail. But it has 3 criteria for whether or not your tree hashing mode is secure. The second one is the easiest one. Do you use all the bits of the things that you're hashing? Because if not, collisions are trivial. Just change one of the bits you're not using. Number 1 is to prevent collisions by disallowing replacement of internal nodes with leaf nodes. So those of you that are familiar with the way that Bitcoin does Merkle tree hashing, it does not do this. It's kind of protected by the fact that usually hashes don't look like transactions, and so you can't replace 2 transactions with a hash that is 1 transaction. So, I should have gone into more detail about how we do this. So we use all the bits, and then we prevent extension attacks by making internal hashes different from the final hash. So we do 3. Perfect. So we do 3 the same way that Blake 2 has a specification for tree hashing, and we use the same flags that its tree hashing does for 3, but so it has 2 finalization flags, and we use those finalization flags only at the root. Because this is a streaming tree mode, specifically it's a tree streaming tree mode, meaning that the structure of the tree is not known ahead of time. Several of the things that Blake 2 does in its supplied tree hashing modes assume that you know the structure of the tree ahead of time and can compute it. And that's not the case for what we're doing. So, but this is fine because we don't publish a whole tree, we just publish the root, and so it's okay. We don't have to, there's not any ability to, there's not any ability to do extension attacks. And then the way that we handle number 1 is that when we configure the hashing, when we do the merging, we specify the number of as one of the inputs to the configuration block. We specify how many child blocks were present, and we hash those first. So you can't replace those with data because that number would change. And one unique thing about our hash tree mode is that usually tree hashing has data only at the leaves, but in our case, you can have a merge, and then there's additional data that goes along with that merge, and we handle that by doing because the way that we handle that is the merge is known ahead of time, and then the data streams in afterwards. And so when we do the merge, we know the number of children because we do the merge at receive time. Okay. Go away, mouse. All right. So how do we seed this pseudorandom number generator that we can split and merge? So my initial idea was to seed it with the user, timestamp, and code, or the hash of the code. So in general, this works. There's nothing inherently wrong with this. It's perfectly secure. The reason that we decided not to do it this way is that a user might want to sign a name that gets generated and put the signature of that name in the code. And general hash quines are not a solvable thing, and signature quines are probably even worse. So that's a no-go. So instead, we just use the tuple signing key timestamp, and that's a simplification. But basically, all of the parts of a deploy that do not depend upon the code are used to seed the random number generator. And the user has control over those because they're going to send it to the server. So they can arrange for that to so they can arrange for the signed names to be in the code that they send to the server. All right. So we have plenty of time. So are there any questions about the deterministic unforgeable names, or do people really want to get to the spatial matcher? Yeah, so if the hash function turned out to be weak and users could generate collisions, then yes, that would pose a problem. But we're very much relying in lots of other places on this hash function not having collisions. If Blake 2 has collisions, yeah, we're kind of hosed, and we would hard fork and use a different hash function.
Yeah, like you're saying, I'm not under any illusion that this would ever happen, but how would the computational model carry out in the extremely unlikely chance that there were a hash collision? Like if I were to send out an unforgeable name and someone were to receive a name that happened to have a hash collision?
So in that model, you would basically have forged the name. So, I mean, the model for that is straightforward. You just succeeded in forging the name. And in fact, one of the things that we want to do is for users to have an explore mode where they have a full node that has a tuple spacer, and they can run code that forges unforgeable names. Because that would be really useful for figuring out what's going to happen, or checking a balance, or checking somebody's balance for which you don't have the public key, or finding out what would happen if a signed message arrived, this thing happens. So what if I just make this thing happen, and then what happens? So we intend to allow users to forge unforgeable names off the blockchain as a way of exploring and figuring out what's happening on the blockchain. So it would basically be, you could do that on the chain. Oh yes, one of the things that Mike pointed out is that on the blockchain, when you go to send or receive on a name, we will check that somewhere in there's an unforgeable name. You have to walk over the whole thing because names are constructible. But if the whole thing is forgeable, we'll just ignore it completely. The reason for doing this is that that allows you to take if you make those have no effect, this allows you to take a piece of code that someone sends you and confine it by going through and taking all of the unforgeable names and writing them to different ones. And then using the spatial matcher, you can invoke that code and know that no secrets leak. Yeah. And I'm at the end, if there's time, I'll actually, I'll go over the registry that I've been working on. I wasn't working on it at the time the topic was assigned, but it's been on my mind, and I'm sure that there are people in here interested in how it works and why we need it. All right. Were there any other questions about the deterministic unforgeable names? If you think of one, we can ask them at the end, too. All right. So let's talk about spatial matching for a little bit. So what's the difference between spatial matching and structural matching? And the main difference is that they use the term spatial matching for the case where it's commutative. Basically, all of the terms exist somewhere in space, and we have to find out where they are. In the literature, the spatial types usually include and, or, and not. And that's a good summary of what we have in Rholang. There are also some other terms. One of the things I want to point out, Mike mentioned in his talk previously that you have the way that you get a grammar for spatial types is you enrich the grammar for the terms with various matchers. In our case, Rholang only has one grammar, which is the grammar for patterns. And what we do when we take Rholang's source is we make sure that you've written a pattern that has exactly one element in it. And we reject anything that matches more than one thing. There shouldn't be a third bullet there. Oops. All right. Okay, so what's the difference between spatial type checking and spatial matching? And the difference is capture. So if you have no capture variables, what you're doing is you're just spatial checking against a type. So capture behaves mostly like a wildcard or true in a spatial type checker. Like a capture variable usually behaves like the predicate that matches anything in a spatial type checker, with one very important caveat. I'm going to go over the caveat. I know that there's been a lot of questions and it's kind of tricky. So let's go over this mostly. At the top level, they behave exactly the same. So the capture variable x will match all the programs that the underscore will match. So where it starts to change is when you have bound variables. So the binders in Rholang are match and for in contract. Contract is just sugar for a replicated for, and new. All right. So let's go over this example in some detail. Whenever I'm doing matching, I always refer to the thing to being matched as the target, and the patterns as the patterns. I think it makes it clear. So if this is our term and this is our pattern, it will match this first pattern. So this y we'll assume is basically arbitrary, and that underscore matches anything, so whatever y is, underscore matches it. And this body is underscore, and that will also match anything. You'll note that this doesn't have any capture variables, so it's essentially doing a type check. All right. It won't match this second term, and the reason is that p is a capture variable, and this target here mentions this x, and this x is bound right here. So because matching allows you to take something and rip it out of context, if we were to match p with this term, we wouldn't know what to put in for x, right? If we had a type that was term with n holes, then you could conceivably match p with this, and it would end up being lambda x dot x bang star y, and you'd have to supply some x. But we don't do that at the moment. So I don't know. But that's what you would have to do in order to allow a match of a capture variable against something that would otherwise have a hole in it. You would basically produce a lambda that filled in the hole for you.
Yeah, actually, I tried this. I had like contract foo, and foo was unbound, and I tried to do new foo, and then when I matched inside, it didn't work.
All right. That actually sounds like something different, and you may be able to fix that second one. All right. All right. So, what? Okay. All right. So, one of the things that we would like that you would often like to be able to do is to create a pattern that references some variable that's already bound. And in that case, so here's a simple example. The thing in question right here is equals star x right here.
This is a pattern, to be clear.
Yeah. So this is just a Rholang fragment. So if we execute this, we'll allocate two new names, x and y. We'll send the the unwrapping of X on Y. And then we will expect on Y something that is equal to X. That's what the equal star is. If, yes.
Just wondering why you wouldn't be able to do star X instead.
So, no. So the equals is important. Star X wouldn't be the right pattern, the right syntax.
Well, if you just said star X, you would be expecting to receive a process of the form star some name. But by the time you have received it, all the stars have already been carried out. And so that pattern would never match. This one is at equals star X. The equals star is saying, grab me the thing matching the variable X that is declared outside. Otherwise, X itself would be a new binder that shadows the other one.
Yeah.
Lambda calculus, for instance, you could say lambda X dot something. It's the inner X that shadows the outer one. Here it's reaching out and saying, no, I want the one that's already defined above this.
That says use the X from line 1.
Yes.
Yes, that's what the equals does. So there's two forms. There's equals X and equals star X. And equals star X is for names and equals X is for processes.
So those are two different syntax constructs?
Yes.
Why is that, by the way? Why can't we come with a single one?
What?
Why we need a simple syntax construct for that be enough? I mean, treat whatever is on the right side as a value.
Because we have both names and processes.
Yeah, they're different types.
And you wouldn't be able to parse it if you didn't know what the binding of that variable was, either as a name or a process.
Yeah. That's why there's two of them. Just like there's two syntaxes for use this variable right here as a process. One is this variable represents a name, that's star, and the other is just the variable itself. And they behave identically. All right. So this allows you to write patterns and match against things that where you don't know, where you can make the pattern refer to something that gets bound. So they don't necessarily have to, it's concrete when you execute it, but it doesn't have to be concrete when you write the program. All right. So, what was this? I should have talked about the logical connectives. So we have and, or, and not. So you can specify two patterns, and we use we didn't want the symbols to conflict with the Rholang symbols that. So we use / backslash to make the up arrow, to make the up hat for and. There's a you can. Oh, hold on. Yeah, let me do that. What was the question?
Well, he just suggested pulling up the two.
Yeah. Oh no. What? No. Oh. This will work. So
Probably just search
Uh-oh.
It's Rholang tools.md. Kind of, you get to feel our pain looking for docs.
What?
You get to feel our pain looking for docs. Good teacher.
So Mike? Yeah. What I meant to ask is why not just X, right? And you're saying because that would bind it to a new version of X that was shown. Yeah.
While Kyle is looking for this, if I say for X from some channel,
Yes.
it matches everything.
Yes.
And if I say for star X from some channel, it matches only names.
No, if you say for star X from some channel, so when you are reading from a channel, you're going to get a name. Right? So if you say for X from some channel, X is in name position, therefore it will be bound to whatever name you receive. If you want to use something other than just X, you have to say what the quoted process is. So you say for at some process descriptor with free variables in it from some channel. So for instance, say you were expecting a list with two parts. You could say for at open bracket x comma y close bracket from some channel. In that position, x and y have to be processes. So now x is bound to the process in the first position and y is bound to the process in the second position. Now say you wanted to get a list of two items where the second one was a variable, matched a variable you've already defined outside. So y would say the process 5, right? So then you could say for at open bracket x comma equals y close bracket, and that would insist that whatever was in the second position matched the variable, matched what that variable was bound to outside, rather than shadowing that variable in the body.
I understand the part, but I'm not sure I understand what's the difference between star X comes from the channel and
Star X is never a good pattern.
So if you said at star x from channel, right, you've got to have the at sign because it's a name. But then the process that was quoted, you're saying it ought to be a process that is of the form star something. But any process that's being sent has already had all of the stars removed.
so it doesn't make sense.
It doesn't make sense.
Probably could just as well not compile.
How much is star X?
Yeah, once we have a type checker,
It's kind of like that channels are, your names are constructed for processes, not the other way around.
yes. I mean, processes contain names, but they're not. Yeah.
Okay, so we've got the connectors.
Yeah. So there's and written, right? Like, so this one right here, like it, you might as well. It doesn't actually gain you that much because you know that the grade is 10, and you therefore you know what x and y are. Well, no, it's a good example.
It's nice because you got the parts of the matched thing or else. You basically deconstruct them in
Yeah,
a security way.
The database was really good.
yeah. The
The SQL people thing.
yeah. So in this case, you can get someone. So this will match grade being anything or anything being 10. It's also kind of a overly broad pattern.
But that one doesn't work, right?
What? Oh, no, it works.
No, he's saying that because it's in OR, X isn't binding.
Yes. Okay, so this is an important detail. So the X and the Y here, because they're at the top level, will match anything. But they aren't actually available in the body.
So why not just use underscore for that?
All right. So in this case, because they're at the top level, it's equivalent to using an underscore. But if you had an X or a Y inside of some body, it will only match if it's something that could be captured. So because underscore is strictly more powerful than a capture variable, we allow you to use a capture variable, even if the result isn't necessarily available. So the reason it's not available is because when this matches, either X or Y will be available, but not both. And we have, and so inside of the body, which one do we make available? If you really need to know, you can use match to figure out which specific case occurred, and then match will make the binding available.
But so that's not illegal. You just don't know which one, so it's like maybe X.
No. It's not illegal. All that means is if you try and use X in here, we'll complain that it's unbound.
The match question that you're saying means you would receive something from the channel and then you match, and if it doesn't match, you put it back in the channel.
No. What I'm saying is if you have something and you know that it's this, that it matches this pattern, you can use match to figure out which of the two things it is.
But that's only if you do like add, input and then capture.
Yeah, if you've captured the whole thing, or if you have if you're using match and you know what it is, right? If you happen to know what it is.
So in particular, this example is showing that you can use X and Y on the left and right of OR, but they won't bind to anything. They won't capture anything. You can't use them in the body. If you use X and Y on the left and right of an and, you can't, because both of them are guaranteed to be available if it matches.
So what does bind in this case? Anything?
No, nothing binds in that particular case.
Would it be more clear if you would be forced to use wildcard in this case?
The problem is that they don't have the exact same meaning.
I don't see any.
Can you give an example where for this pattern it wouldn't be the same? I mean, so we would have a term with a whole matched. Next, say.
Well, the reason being is, like, sometimes if you have things in OR, like, in a single term in the OR, you might have X multiple times when a match that is in those places. So if you were forced using wildcard, you couldn't do that.
So you can use the name inside the pattern and like being the same thing or in several places.
Yeah, just it wouldn't match
Yeah,
because you'd have different things in the OR
Okay.
in the other places.
I got it.
And just to clarify, you're not using the old syntax anymore, like ampersand stuff?
No. So for the spatial types, they've always been tilde for negation, this union operator for or, and the hat for and. So this type right here, Ovidiu, this pattern, if I replace that, if I replace this with a capture variable, I get a different pattern, has different meanings. Yeah, we already did, we can go back to the other slide.
But if you put a Y there, for instance, suppose that new X in whatever was there uses the variable X.
It will only match. It only matches something that could be captured, even though it doesn't capture it because it's contained in an OR.
But my question, because in that example where we discussed that there is a difference, well, in principle, there is a huge difference between an underscore and a variable in a pattern, especially when we're not on detailed level. But in that particular example where we've got the grade and the student thing, I'm not sure if it's possible to create a tar that would actually lead to capturing unbound variables. So that may have
Yeah, there is a difference between the top level and what's bound. But in general, it's probably not worth the effort to try and like save the user from themselves, right? Like ORs just don't bind. Right, and some of the patterns may very well be generated from macros or something like that. Oh, okay, go away. All right. Where is the SQ? Oh. Does this use, yeah. Yeah, it uses and to capture the whole row.
Can I ask a question about this? Let's say you actually had a database called people and you wanted it to not be leaking out. So let's say you had a database called here's all my persons. In this case, you wouldn't want to send, at pers to something. You would want to make a composition that included, say, like, the database as part of the name, such that it can only be accessed through that context. Like right now, anyone who's listening in eyes can hear great outside of this.
No. So, I think you're, okay. So let's talk about why that's not correct. So, and anyone that's listening on eyes will never hear a thing. No, because this is a Rholang term that's being sent. So we're sending this term. We're sending an actual program fragment on people. We aren't executing it. So nothing ever gets sent on name. There aren't any listens on there. We're just using that as a way of representing a key value map.
But if we dereferenced that program, we would execute it.
Right, if we said star row in the body there, then it would send on name. But until we say star row, it's just that the row process itself isn't executing.
Let's start with database rows.
All right. Do you guys want to talk about the registry? All right. So I'm just going to close this. And I'm just going to talk about it a little bit. So the way that the registry is designed is that essentially it's a giant map. And the map goes from keys to processes, right? Like to Rholang terms. And the way that you use the registry is the registry is a trusted source. It allows you to take a name, and it allows you to take a piece of data and get back a name. In the Rholang syntax, we created this idea called a bundle. A bundle gives you two things. And Mateusz, way in the back, he implemented these. So a bundle gives you two things. Number one, it allows you to prevent people from pattern matching on the contents of a bundle, right? So so you could use this to give someone a piece of code that they can either execute or not at their choice, And that code could contain an unforgeable name, but they can't take apart the bundle and take out the unforgeable name and then do something nefarious with it. So the bundles are one of the ways that we're going to use to verify that the wallet you give me is the same currency as the wallet that I'm accepting, so that you can't turn lead into gold or into rev. Yeah, it's a proof of shared lexical scope. Because otherwise you have to have one process that's a trusted authority, and you send a message to that process saying, is this wallet also the same currency? And so there's this bottleneck. But with bundles, we can just, everybody has a copy, and nobody can take it apart and change it. And so you can just use bundles in that case. But they also allow, so that was the idea. We also added the ability to take a bundle and remove the permissions to send and receive on that. So that if you quote that bundle and it only has the right flag, you're only allowed to send on it. But when we encounter a send on a bundle, if the process is exactly one bundle, then we check the permissions and we reach inside and we perform the send on the thing inside. So this allows you to take and register a bundle in the registry, and then retrieve, and then you can publicize it. So anyone can send you messages, but people can't pretend to be you and receive messages intended for you. So that's why the polarity is important. And so in order to bootstrap this, we use a URN. I don't know if you've seen how we do standard out at the moment, but we're going to use something like that as well, so that you request a copy of the registry and you get a bundle that only lets you send to the registry, so that you can't pretend to be the registry, so that we it kicks off, that's the base case of the induction step, where as long as you keep getting unipolar names from the registry, you can never pretend to be somebody else. Because what you don't want to do is to give somebody, right, like you register your wallet address at some URN, and then somebody goes and looks it up, and then spawns 10,000 listens on that name. So that there's only a 1 in 10,000 chance that when somebody tries to send you money, you actually get it. So that's kind of the registry, why we need it, how it's bootstrapped. The way that we implemented it is a giant map. But using a single Rholang map where we read it in, we add something in, and then we write the whole map back, that doesn't scale. So instead what we did is we implemented it as a radix tree. And it's actually stored in the tuple space, and we read out a map of 1 byte keys. And I don't know, you can go look up radix tree on Wikipedia, but we use single byte fan out, and we store that. The actual URNs that we're going to give out will be base 32 encoded, and they'll have a CRC, so that when you write them down, we can tell you whether or not we can tell you with a reasonable probability that you've made a mistake in transcribing this. No. I implemented an efficient map by doing a Patricia tree.
But did you implement that in Rholang, or did you add it as a primitive?
So I implemented it in Scala. There's no reason you couldn't implement it in Rholang, except that I take advantage. I think we have the array slicing now, so you could write it in Rholang. There's nothing special that it's doing.
So the map that is provided natively as a data type is synchronous, and you get the entire thing as a value. If you want to have a map that can support concurrent operations into it, then you write it in Rholang, and then you just put maps on the leaves or something.
Yeah, so that's the way that we did it. We wanted it to be the case that if you looked something up that wasn't registered, you got an answer that that's not registered. That you didn't just wait around until somebody managed to put something on that key. So one of the reasons I implemented it in Scala is I wanted to give an example of how you would write a system process in Scala that had to do a bunch of tuple space operations. Sure.
One is when bundles compose, is the resulting bundle union restriction?
So yes, if you have a bundle and you bundle it up, we do collapse. If you take a single bundle and you wrap it in another bundle, we do collapse the permissions to the least permissive.
And the second one would be with the at equals construction. Could you put something that is like a pattern?
No, so the at in that example is just because it's a name pattern. So you can ignore the at. And so that the so if you quote a name pattern, or if you quote a process pattern, you get a name pattern. So equals x is a process pattern that gets exchanged, that gets rewritten to this pattern must, or whatever is here, must be exactly the value of x, which is why it's equals.
But I think the question is whether we could write equals whatever patterns, let's say is equals 4 and stuff like that.
Well, actually, no, I was thinking it actually doesn't work because you can't have like some process somewhere with top level free names.
Yeah, so no, the only thing you can put after equals is a variable. If you needed some more complicated process that referred to the variable, you could just write that pattern, and then in the slots where you need that variable, just put equals x.
Can you interrogate or match against permissions?
Can you interrogate against the permissions?
What happens if you try to send a read-only bundle?
Right now we throw an error, and so your deploy will fail.
But if you don't know when you're getting it.
Then your deploy will fail. I mean, if somebody sends you a read-only thing and you're expecting to write to it, then there's nothing we can do to recover from that.
Can we write bundle with the buffer? I mean,
No, yeah.
They're paying for the send, right? They send you a read-only thing. You say, I don't know what this is. Their send fails.
So, yeah, we could probably make it so that you could interrogate against the patterns and make sure that you have the correct patterns or correct permissions, but we don't have that at the moment.
So you said before, if you merge bundles, you collapse the
So
permissions
I need to be specific. If you take bundle of x and you take bundle minus of x, if x itself is a bundle, you don't get bundle minus of x. You just get bundle minus of its whatever was in it. So we collapse them, but only if you wrap something that is one bundle in another, and we take the least permissive. So if you have something on which you could only send, and you say bundle minus of bundle plus of p, you'll get bundle 0 of p.
If you take bundle minus of bracket bundle plus of p, that is a completely different name when you've got
Sure. It's basically a structure that says there's a term inside here, and here are the permissions. And when you go to send, we check, are you sending on one of those? Is the term exactly one bundle? And if it is, we check the permissions, and then we do the send on the inner contents. Bundle allows you to create the IO pairs. So you can just say new X, and then when you're giving it away, you could just say bundle plus of star X. Or so when so the reason you would use IO pairs. Yes. This bundles subsumed that functionality.
When it comes to pattern matching, so if you have like new X, blah 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 blah, but you pattern match it, so you don't have anything where like X will be unbounded. You have X articulated with the pattern of the body of the new. That matches and it constrains the matching unit. Like
Can you submit this in writing?
So new X in star X is a valid pattern, and it checks the
Oh, yes. So you can use variables that are pattern-bound variables in a pattern.
okay, yeah.
All right. Are there any other questions? Sorry I didn't get something written up about the registry. I was too busy writing the registry. Thank you.